Hi, math lovers. Let's talk about sets of numbers here. So here are the formal definitions of the sets of numbers. But what I want you to do is take a look at my notes that I have right here, this graphic. This is just a beautiful graphic, and this is what we're going to talk about today. So these are all the numbers that so far that we've learned. The big title would be the real numbers. Those are all the numbers used in Algebra 1. Those are all the numbers that you can find on the number line. We can break real numbers up into two groups. I like this graphic because you could see there's one set which is rational and one set that is irrational. So numbers are either rational or they're irrational. They can't be both. We call that mutually exclusive. Okay, so numbers are either rational or they're irrational. Take a look at all of the irrational numbers that we have here. Notice that the irrational numbers cannot be expressed as a fraction. Those are numbers that when you write them as a decimal, they don't repeat in a pattern. Best example of that is pi. There's no pattern when I express, when I write out pi to 3.14159. The pattern continues, the decimals continue on and on forever and ever and ever. All right, so now let's concentrate all of our energy on the rational numbers, all about rational numbers. The first set of rational numbers are just our fractions, like our rational numbers like 4/9, -5/8, 11/7, all of those irrational numbers. Gosh, I said the wrong word. Hope I can edit that one out. All of our numbers that are rational, we can write as a fraction. Okay, so again, irrational over here, those numbers can't write as a fraction. Rational over here, we can write them as a fraction. All right, take the rational numbers, break them up, and separate into integers. Our integers, there's a smaller group, a subset, which we talked about yesterday. A subset of the rational numbers are the integers, -11, -6, -3, -2, and so forth and so on. I'm not so wild about this definition of integers. If you go back up to our definition of integers right here, we have our integers given to us as this set, okay? Whole numbers and their opposites. We like to see our integers as a complete set, -3, -2, -1, 0, 1, 2, 3, and so forth and so on, all right? I can take that set of integers and break them up into a subset. So I can take the integers and just take this subset of them. And that's what's called a whole number. Okay, a subset of those numbers is a whole number. Then I can take another subset. There we go. Another subset and of the whole numbers. And I can have just leave out the 0 and just start with the 1. Those would be the counting numbers. Those would be our natural numbers, okay? So lots of definitions in this lesson. I go through an example here where you're identifying all of the natural numbers, the whole numbers, the integers, the real numbers, and so forth and so on. Pay careful attention that there's more than one for each set. And notice how they try to get you with this -12/4, that's really -3. So when you go through your problem set, look at that. Let's look at the numbers first and let them talk to you. Have fun with your problem set.